Hello guys, in my last video I've explained you about Euclid's division lemma. In my today's video I'm going to explain you how to solve some of the problems based on it. So today we are going to solve NCERT chapter number 1, real numbers exercise 1.1. So our first question is, use Euclid's division algorithm to find HCF of 135 and 225. So as I've explained you earlier, we will apply Euclid's division algorithm on these two numbers to find its HCF. So now since 225 is greater than 135, we'll write it in the form of A equals to BQ plus R. So 225 is equals to 135 into 1 plus 90. So here 1 is Q, that is the quotient, and 90 is the remainder, that is R. Then as R is not equal to 0, so again we have to apply Euclid's division algorithm between 135 and 90, that is between B and R. So 135 can be written as 90 into 1 plus 45. Again 45 is not equal to 0, so we'll write 90 is equals to 45 into 2 plus 0. So here we have got remainder as 0. So HCF will be 45. So its answer is 45. Now our next question is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So now let us consider a as a positive odd integer and value of b will be 6, as we have to represent that odd integer which is a in the form 6q plus 1 where 6 is b. So now I'll tell you where you can get this b from. How can you decide that what you have to take the value of b? So the equation of Euclid's division algorithm is a is equals to bq plus r, and we have to represent the odd integer which is a in the form of 6q plus 1. So here value of b will be 6. That's why we have taken b as 6. Now let us see some of the odd integers. So odd integers are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and etc. So we can write these integers in the form 1 we can write as 6 into 0 plus 1, 3 we can write as 6 into 0 plus 3, 5 is equals to 6 into 0 plus 5, 7 is equals to 6 into 1 plus 1, 9 is equals to 6 into 1 plus 3, 11 as 6 into 1 plus 5 and 13 as 6 into 2 plus 1 and so on. So from this we can observe that after dividing any positive odd integer by 6, we are getting the remainders as 1, 3 and 5. You can see this pattern 1, 3, 5, 1, 3, 5 and so on. So here we will take value of r as 1, 3 and 5. Therefore we can represent a, which is the positive odd integer, in the form of 6q plus 1, 6q plus 3 or 6q plus 5. Now the third question is, an army contingent of 616 members is to march behind an army of band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So in this question we have to find a number of columns which are common in both of them. So for this we have to find highest common factor between these two numbers. So again, we have to apply Euclids division algorithm between these two numbers. So again, as 616 is greater than 32, so 616 can be represented as 32 into 19 plus 8. Again, 8 is our remainder, which is not equal to 0. So again, we'll apply Euclid's division algorithm between 32 and 8. So 32 can be represented as 8 into 4 plus 0. So now our HCF will be 8. So our answer will be the maximum number of columns in which they can march is equals to 8. Now our next question is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So now let us consider any positive integer as a, and again, as we have to represent it in the form of 3, so value of b will be 3. So now let us write all the positive integers 1, 2, 3, 4, 5, 6, and we can represent it in the form of 3 into 0 plus 1, 3 into 0 plus 2, 3 as value of b is 3. So 3 is equals to 3 into 1 plus 0, 4 is equals to 3 into 1 plus 1, 5 is equals to 3 into 1 plus 2, and 6 as 3 into 2 plus 0. So we can observe that our value of remainder will be 0, 1, 2, 0, 1 and 2, as value of r lies between 0 and b. Therefore, value of r will be between 0 and 3. So value of r will be 0, 1 and 2. Therefore, a, which is the positive integer, it can be represented as 3q plus 1 and 3q plus 2. That's it. So now, as it is written in the question that we have to represent, we have to show that the square of any positive integer. So let's square the number a. So if we square a, so a can be represented as 3q. So a square is equals to 3q whole square is equals to 9q square. Let's take 3 common from it. So 3 into 3q square is equals to 3 into, let us consider this 3q square as m. Okay, then next again, a can also be represented as 3q plus 1. So a square is equals to 3q plus 1 whole square. So we can apply a plus b whole square formula, a square plus 2ab plus b square. So 9q square plus 6q plus 1. So let's take 3q common from these two numbers, and then 3q into 3q plus 2 plus 1. Let us consider this entire value, this one, as m, so 3m plus 1. So this is how we can represent any positive integer in the form 3m or 3m plus 1. Now our next question is, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So it is same as the earlier question. So I hope you all can solve it by referring the previous question. But if you have any doubts regarding this question or any other question from the exercise 1.1, so you can write it in the comment section. I'll definitely try to help you out, guys. So thank you for watching this video. That's all for today. Have a nice and great day ahead.